All right. I think so. Yep. Okay. So the topic today is functional with JavaScript arrays. It's a little bit of a reboot from a couple that were done over a year ago. Who was here for those? Raise your hand. Sorry if it's boring. So we kind of revised and updated a little bit and clarified and basically wanted to have this topic again because it's a powerful one and a lot of power you can use here in your application. So first, let's talk about like why functional, right? So question, is this just hipster hype, right? Seriously, raise your hand if you think it is. It's just hype. Okay.
It's not that it's just hype, it's just that it's a lot of hype.
It is hype. Raise your hand if you think there's hype around it. Raise your hand if it's just hype. So everyone perceives there is some substance behind the hype, yes? So not just one of those phases, or is it one of those phases, or just another thing? Is this a big deal or a little deal or just evolution or what?
I think it is a big deal, but I don't think it's as big of a deal.
It's not. So the hype outweighs the substance, maybe?
It's a pendulum.
A pendulum?
We tend to go a little bit too far in one direction. We went a little bit too far in the other direction. Now we're swinging back a little more to the functional direction.
So
Hopefully we don't go too far.
this could be a hybrid eventually is where we'll land, somewhere in there where it makes sense. I agree with that. Is this true or false? Does this style of programming, would it lead to increased productivity, less bugs, reusable code? Is it fun? Raise your hand if you agree generally with that statement. And for those who don't agree, have you tried? One way to find out. So basically what it's about is going from how to what. Okay, that's really what this is about. And so for instance, we're going to look at this mystery operation and we're going to determine what it does. Okay, what does this do? And if we kind of analyze the code, right, that's kind of the how. It takes an array of numbers. It creates an iterator, a sum variable, and a new array. We iterate through the original array. We push to the new array the value at the current index of the original array, but we multiply it by itself. So we're squaring it, right? Everyone with me? And then we iterate through that new array of squares, essentially, and we add the value of each to a sum variable. So we just described how it's doing something, but what is it doing? Someone want to just summarize what it's doing? Then it returns sum, right? So let's change the conversation from how to what. So abstractly, what it is doing is it maps an array of integer to an array of its squares. So a mapping, right? And then it reduces that array of squares to its sum. So down there in code, that's the exact same thing, but instead of kind of focusing on the hows, it's the what. So our code, the code of what we're doing and how we're doing become the same thing. And that's really kind of the goal of declarative programming styles or functional is just a subset of that. But it just changes the way we write code from how to what. Does that make sense? Questions? So if we look at another one, same thing, right? What is this doing? Using that same context of what versus how, what is this doing? It's kind of hard to figure out, right? Yeah. So what if we kind of rewrite it to the instead of the how, we write it to the what? So we have an array of numbers. We filter it by, we only take the things that are even. We map those even numbers to their halves, and then we reduce it to an average. And that's what that same code looks like when you change it from the how to the what, where each of those, where even is just a function, half is just a function, an average is just a function. With me? So this is kind of the foundation of the rest of the talk. So just the important thing is to understand the difference between how and what, right? Changing our style of programming from telling the computer how to do something to telling it what to do. And that leads to code that's, gets all those benefits we talked about earlier. Everyone agree, disagree, questions? We good? Move on? So take array of numbers, filter out the odd ones, map two halves of each. Basically, the pseudo code is exactly the same as the code at the bottom of the functional style, right? I mean, it's the same thing. Very easy to read, very easy to understand. There's really no question as to what's going on. We wouldn't even have to really even give this function a name. We could just have those list of operations in a row, and it tells you exactly what it does. Good? Yeah? You guys awake? So let's take the same idea, the idea of going from how to do something to what, and see if this idea scales, okay? So let's talk about an app, just in general, your whole entire app. That was just, that was just a little process, a little function, right? Does this idea of going from how to what scale all the way to an app? I think to do that, we have to figure out what an app does. So in an app, there could be things, and things can have names, things have functionality. Things may have data, and they expose the way to interact with other things, and they can be very domain specific. But all that is the how, or a how. But what's the what? I mean, what does an app do, right? So from that same kind of that abstract point of view. So true or false? Is an app just a long-running process in which an asynchronous series of events are transformed to effects? I mean, is that a very high level, abstract level? Is that an app? Yes, no? Disagree? True, false? True, raise your hand. False, raise your hand. Half of you didn't even raise your hand. So let's just take a look at that same sequence of events, okay? So you start with some data, an event typically. It's all data, but an event, some initial state, right? If you have an app, that's just a long-running process, and all it does is sit there, it receives an event and data, goes through a bunch of transformations, you end up with an effect, okay? So the start is some event, some state, right? That data plus event flows through a series of transformations, 1, 2, 3, 4, right? And in the end, you end with some sort of state mutation or some effect. Something happens to your app. Okay, with me? Agree? Go on. Okay. So essentially an app listens for events, pipes them through transformations, sends them as effects. That's abstractly what we're claiming here, right? That's what it does. So you guys buying that? Maybe? So let's give some examples. What's something that's at the start of this thing? Your app started. That's an event. That probably has some data associated with it, right? DOM events, right? They have some data. You can grab some state based on that. Maybe you're creating a web server. You get an HTTP request. That's an event that has some data. Maybe you're on the other end and a response came back. That's an event with some data, right? Something to start with. Database result, WebSocket message, etc. So these are all events that have data, something that typically your app is going to respond to. And like I mentioned before, state is data, event is data. So really, it's just all data. Data's just coming in somewhere, right? Something causes data to come in. You take that, and it does something, okay? So let's look at the end. What's the very end thing that ends up happening? You end up rendering or updating the UI. Maybe you trigger another DOM event. I mean, maybe that's the effect that happens. Maybe you create an HTTP request. Maybe you return a response. Maybe you save information to a database. Or you send a WebSocket message, right? So we have these things happening here. And they lead to things happening there. So a start and an end, and then some stuff in between we haven't really talked about, right? Just the easy stuff. So there's a couple ways you can take the approach here. You can create a bunch of things that have imperative operations, like, my cat set attribute, or add grade, or remove record, or all this. But you think about it, all that's kind of how, right? I mean, that's how you're doing stuff, but what is it you're doing? What do those things do in the middle? And so what we try to do is kind of align the idea of how and what. Make them the same thing, okay? So between start and end, we can think of data, right, event plus state, streaming through a composition of transformative verbs. These verbs describe what the transformations do, okay? So we have data, some event, it comes through, it's going to go through some stuff, it's going to have an end. But what is that? Well, it's maybe you're filtering, we're slicing, we're mapping, we're reducing, we're concatenating, we're zipping, we're forking, we're flattening. Okay, these are all transformative verbs. So basically you get data in, you go through a series of these verbs, data goes out. With me? Not with me. So obviously it's not always this simple, right? So it's not necessarily always this nice and easy to think about. Sometimes it looks like that. Or that. 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 Sometimes one end is something else's beginning. Is that a song? But nonetheless, all those transformations in the middle can be represented with those verbs, right? Basically, I just went through and I described a fork and then a zip, some stuff in between. Those could be filter, maps, concats, reduces, whatever. At the end of the day, data's coming through. We're transforming that data. That starts as an event in some state. We take that, we do a bunch of transformations, and that ends up being something else, okay? And at the very end result are that these things right here, these initial things that came in, they're effectively mapped to these things. And that's kind of the foundation of all this. Agree? Disagree? Comments? Questions? Okay. Who said that? Thank you. So bonus. And kind of in this paradigm, if you follow some rules and best practices within these things in the middle, you get some extra perks, okay? Those things in the middle become very reusable because they're not domain specific, they're actions. You're slicing things up, you're transforming, these are things that aren't necessarily tied to a specific domain model. It's just they're transformative functions, okay? They're easy to maintain, they're very testable because typically they're pure and stateless, and you just worry about them in isolation. And they can have a simple mental model because you don't really, when you're working on one of these things here, you don't care necessarily about the whole entire flow of everything. You're just worried about one little thing. And then you talk about scaling your app across cores, across processes, across the world. With some of these best practices, it makes that easy. You don't have to worry about state management between each of these things. So verbs included many libraries, functional libraries in JavaScript, and obviously there are functional languages that have these things built in. But in JavaScript, there are libraries that give you these things, like ramdun, underscore, and lodash. They give you maps and filters and reduce and zips and concat and a whole bunch of other things that basically help you to create that stream of transformations, okay? And then things like observables, RxJS, they essentially turn all things, really, that change into these things that can be mapped, filtered, reduced, concatenated, right? Those mouse clicks, just anything that changes over time. This provides kind of an API to map and filter and reduce all those type of things. So it's like an array over time. With me? So yes, the sign said JavaScript arrays. So let's kind of bring it back to that, okay? So this is an adoptable concept, meaning you don't have to, like, if you don't want to, you don't have to make your whole app work in this paradigm. I mean, you can just take certain parts of it and make it work in this paradigm. Kind of like Robert was saying earlier, it's not like a choose this or that. It could be choose both where it makes sense, okay? And so in JavaScript, typically the data flowing into our app starts as an array. We get data from an endpoint. server side, we do a database request. Very often it's coming back in the form of an array. So arrays are usually the typical starting point of data for us. Client side too, when we're selecting elements, that's array-like things. We're dealing with things in bulk, okay? And this array of data eventually changes the DOM, or maybe it shapes the HTTP response. But essentially, we are going from an array of things to something else. So I mean, it fits that whole paradigm of start at data, end data, transform this to that, right? And it just so happens arrays in JavaScript have all these verbs built in: filter, slice, concat, map, reduce, for each. Here are the kind of some building blocks to all those things in the middle. So now you know, if you didn't before, that these verbs are associated with a bigger paradigm, right? They're not, I mean, they're just a method off the prototype of an array, but they originate from a different idea. So they come from a different paradigm. And because of that, you can tap into the power that comes from composing those things together. So built in the language, you can use kind of these building blocks and the power that comes from it to scale your app. But to do so, you have to really kind of understand how to use the parts. So we're going to kind of go through, and who's familiar with all these concepts? Raise your hand. Who feels comfortable with everything we've talked about so far? Is this new to anyone here? Kind of a couple of people over here? Okay. So slice, what does slice do? I heard mumbling, but I didn't hear an answer, sorry.
Returns a subset.
Right. So you have some array of n length, and you take a slice of it. It's that simple. This is just declarative. It's not functional, right? There's no functions being passed around, but just a declarative way of grabbing a slice of the array. What about concat? Combine items, right? So from an array of n length to an array of greater than n length, right? So if items is an array, we're concatenated to the end of that. What are we concatenating to the end of that? An array or values?
Values because concat will flatten arrays that pass to it.
How deep?
One level is all I know.
One level. Yeah. So it accepts anything or an array of anythings, and it returns a new array, which contains the previous items. So it's a new array, right? So we're not mutating the original. So there's following some of those rules we talked about before. No side effects, right? Returns a new array where the first part of that was what was in the original array, and the second part are the new item or items. And like we said before, it's not added an array at the end. Actually, if items was 0, 1, 2, 3, the bottom operation would result in 0, 1, 2, 3, 1, 2, 3. So examples here, that top one adds 11 to the end. The bottom one, you end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 object. It's a string. Anyone want to see that, or are we comfortable with that? Raise your hand if you want to see that. Okay. So same idea, we're just going to log through that. On the right-hand side is the result. Want to mess around with that, or are we good? Can you guys see that? Is that big enough? Good? Does that make sense to everybody? So to answer the original question, what if we concat what is that going to do? It's going to flatten it?
Flatten the first one.
So it's just a shallow flattening process there. All right, map. Who's familiar with map and comfortable with map? Who's not? Okay. Map just transforms each item in an array. So you start with an array of n length. Those things contain x's. It could be anything. And what you end up with is an array of the exact same size. Can't remove things, you can't add things. But instead of containing x's, they contain y's, right? So the bottom there, what is that doing? For those that, what is that doing? So if items is an array of 5 things, the result is what? 5 things of its squares. Does it modify the original? New array, it's a copy, right? Okay. So map is a higher order function. What is a higher order function? What? I can kind of hear you guys, but
It accepts other functions.
function that accepts or returns functions. Yep. What's a lambda function? An anonymous one that's typically passed in as an argument to a higher order function or return. Okay? So a map accepts a lambda function, and the first argument of that lambda function is the placeholder of each item as the language loops through the array, right? Whatever you return from that lambda becomes the values at each spot in the new array. Does that make sense? Those that raised your hand the second time when I asked if you weren't familiar, does this make sense? Does this not make sense to anyone?
Think of it like a for loop.
So it's basically looping through for you. You don't have to worry about any of the looping. It's doing all that. All you're doing is you're passing in a function of what you want it to do at each part through the loop. We'll have an example here in a minute. So here are some examples here, right? We have an array of 0 through 7, and we're mapping it. What's this right here? Do anyone know? Yeah. So that was one of 2 features added in ES 2017. So there you go.
What was the answer on that? Is it 2 to the x power or?
Mm-hmm. To the power of x. So the results down below is 1, 2, 4, 8, 16, 32, 64, 28. So is that everyone okay with that? Anyone not okay with that? Raise your hand. Good? No.
Why is it not a caret?
It's just not in the language. I don't know.
Isn't caret a bitwise operation?
It might be, yeah.
Bitwise not.
Yeah, I think carrots a bitwise operation.
Yeah. Before this, you had to actually do math.pow. All right, down below, what's going on there? Who wants to explain what's happening on the bottom one? So we have an array of objects. Each object has a W, H, and D, right? We're mapping each of those. We're destructuring the argument there. And we're returning the volume. You said that earlier. Question?
So it's mapped as W, H, and D. Are those respective to the values inside the objects above? Or if it was in a different order, would they pick first, second, and third?
So this particular case, we're destructuring the object. So it's related to the name of the keys above.
The name is
So you could do it in any order. It wouldn't matter.
Couldn't you, in a just different form, you also just pass in x, and then do x dot w, x dot h, x dot e?
Yep. Yeah, so the question is, do you have to destructure here or no? If you wanted to just pass in x and then multiply x, x dot w times x dot h times x dot d, you could do that.
If we jump into the JS bin, you can convert it for us.
You want me to do that? Good.
Make your text bigger.
Bigger?
Yeah.
Too big?
I'm sitting really far back, so I'm
Bigger?
no, I'm good. Come on, one character per screen.
I didn't hear what Bruce suggested.
He wanted it bigger.
Well,
No, he wants me to basically answer that last question in code.
Okay.
So instead of destructuring, same thing, right? The destructuring sometimes adds clarity to what you're doing, what you're expecting. So it's not necessary. Everyone good with this concept, or anyone not good with this? Does this make sense to everybody? Just as we're, go ahead.
So the entries in the array could have extra elements and they just be ignored, right?
I'm sorry. Oh, the up here? Yeah, we can. Yeah, it would be the same thing whether you destructure or not.
What if they're missing one?
Then you have problems, yeah. Then you have to, so, you know, ideally you have an idea, like at some point in time we talk about data coming from an authoritative source. Like that's a contract, right? You're dealing with that as a contract. That's where you're, you know, that's where structured schemas, you need them. They have to have, you have to start somewhere like that you trust. If you know, throughout the rest of it, you know, because you've derived it from this, right? Does that make sense? So at this point in time, we're assuming that the data started off at a, you know, a structured, authoritative, contractual shape. And throughout the rest of the app, we're able to kind of deal with what we need. So I had one here and then one there.
While you're in there, can you just show us here?
Show you what?
Take off the D, one of the Ds. And
Oh, it would just basically try to say D is undefined, I imagine.
it would still process the rest of the array.
There you go.
Okay.
So now fix it with default values. Structuring. Yes, I do.
Yeah, yeah. I'm going backwards. Oh no. So he said fix it with
A D equals 0 is defaults.
0.
Well, if you don't have a D, there's no height. There's no dimension.
I can live with that. There we go. So now we're saying, hey, if you don't have all the things you need, we can assign defaults. In this case, 0 was the sensible one. There was one here and then one there. Jaime, you're good?
Yeah.
Heron?
Because an obvious area is 0.
So, as you're saying at the contract, about the contract at the beginning of this process,
Uh-huh.
You haven't talked about filter yet, I assume that you will.
Haven't talked about what?
Filter,
Yes.
so you can use filter as a validation step to
Yep.
essentially throw out things that are not gonna go through the process.
Correct.
successfully.
So in addition to assigning default values, you could actually get rid of anything that doesn't meet your requirements beforehand anyway. If the original contract had fluctuation that you had to account for. There was a question over here.
So will the M be lost? That data will be essentially lost after that.
Well, the
So
original array still exists.
this, yeah. So it doesn't mutate this, right? So if we take that and do live coding. So we have this, and then we can actually just do a console.log original. So we go through the same process, right? So the original thing is not modified. It's still there. So it's not lost. It's just, it's not part of this stream anymore, right? Anything else? Questions? Comments? Good? Move on? Okay. Good, because I don't think I have much more content than that. All right, filter. That's what Aaron brought up. Who's familiar with filter? Who's not familiar with filter? Okay. So filter kind of comes as advertised. It just removes things out of the array, right? So it takes an array of n length and it returns an array of n or less length. Okay? So down below, what are we filtering out? I worded it funny, yeah. So what's left are evens. Okay, so filter is a higher order function that accepts a lambda function, where the first argument of the lambda function is a placeholder for each item as you loop through, just like in map, right? But here you just return something that's true or false, or truly or falsy. True means it stays, false means it goes. Questions? Good?
And this is, doesn't mutate.
Same thing, copy. Yep. None of these original things mutate. So there are methods off of the array prototype that do, but you wouldn't want to use them in this paradigm, especially if you look at that whole when we did the forking of a process. If one happens before the other one, and this one mutates the thing before it, you have a big giant bug in your whole system, right? Because this part of the fork is expecting one thing, but the other one changed it. Hopefully that was English. Okay, so what's this top thing doing? What's left? All right, want to see that? Too bad. So the top one before is basically it's a filter based on a function that says, hey, if you're even, you can stay, right? Bottom one is looking for just a regex match of anything that matches bacon. And it's based on, it has to return true or false. So same thing.
I in the middle example is modifier on the regular expression.
Case insensitive. In this case, it's not really necessary, right? Because everything's lowercase, but. So what does the bottom one end up with? What about that one? Right? I mean, this is not super complex. It's just kind of getting familiar with it if you haven't already. It's just a function that returns something true or false. True it stays, false it goes. We good?
So a good use case of this would be you've got a grid of data and you let the user filter and you use the filter function.
Yeah, like if you had like a UI or something that had a bunch of data and that matched keywords by a user, you can run this through this type of filter function that tries to do a string match against that original object, then changing the output, the render, the UI, right? So event, original data, output. Good? Good, move on, keep going. Stay. Okay. All right, here's a fun one. Who's familiar with reduce? Who thinks they're good at reduce? A couple of you? Cool.
I did until you said that.
So what are some things you can do with reduce? Like give me a practical example of reduce. Some, yeah. What else? You can just yell it out. What? Average. Practical.
Writing a chain of transformations, like when you're in the car playing that transformation game where you start with a number, say add, multiply by 2, or whatever.
So I think you're saying composition.
Sure.
Okay. That's on the other hand, I thought. No? Yeah?
Yeah, we had a practical example of reduce where you wanted to transform HTML with any number of these functions. We'll just accept HTML in, HTML back. So you just pass it an array of functions. It would reduce over the functions.
Awesome. Yep. You can reduce it to 42. That's true. I think that would be an easy reduce to make, right? No matter what's brought in, you just return 42.
I'm still learning this, but with JavaScript promises, it allows you to, if you don't know how many, or if you have a then chain, so if you do something, then this, but you don't, you have like a dynamic.
You want to dynamically create a waterfall of.
Right, dynamically chain a bunch of functions together.
Good. It's almost like I planted you there and I didn't, I promise, because that example's coming up. All right, so reduce. It transforms from an array of anything, to an anything. So map was an array of n length to an array of n length, right? Reduce is an array of n length of anything to anything. It could be, the output could be anything, right? So in the case of sum, we take an array of integers and return, or an array of numbers, and we return a number. But it could be, you can use reduce to transform from an array to an array. There's no limit on what you can do, but it's just from an array of something to something, right? And like y could be anything. So down below, what is that reduce doing? Summer concatenation. That was a trick question, and you got it. Yep. So, for instance, you have an array of blue circles, because, we're always working with blue circles. And you need to take that, and you need to make a red square. Okay, I'm only doing this to kind of show how this works as you're going through, because you kind of have to understand the process, because the signature is a little tricky. Okay, so this is what this reduced signature looks like, right? It accepts a lambda function. So reduce takes two arguments, a lambda function and an initial accumulation value, okay? The lambda function takes generally two arguments, right? The first one will be the accumulation as you're going through as you're iterating through. The second one will be the current item as you're going through. Okay, with me? Kind of? Enough to hopefully word this slide makes sense? Okay. So we have our array of circles. Okay, we're going to seed this function with an initial accumulation value, in this case, a red square. A red square is what we want at the end, but we have to kind of build that as we go, right? So the very first time it iterates through, we take that red square and one of the circles, and together they produce a red square, okay? And as we're showing you the parity that happens as we go through. So there we took a red square and a blue circle. And here we're going to take a red square and a blue circle. And here we're going to take a red square and a blue circle. And here we're going to take a red square and a blue circle. And so on, and so on. At the very end, we get a red square. But that's how that's built as we go. So I know that's very kind of abstract. Let's take that with some numbers. Let's just look at the sum again, right? So here we have an array of numbers, 1, 3, 2, 5, 6, 8, right? And we want to take that, and the thing we want out is a number, okay? So we're going to seed that with a number. That's this right here. You see that?
There you go, Jared.
Yep.
Can I ask, what does ACC stand for?
Cumulative in this case. Accumulation current. Right? So to start off, the cumulative value at the very first time is 0, because that's what we're passing in, right? So here we're going to take 0 and add that with 1, and we get 1, right? Next time through, the accumulated value is 1. We give that 3, we get 4. Next time through, the accumulated value is 4. We add that with 2, we get 6. Make sense? So this is important just to recognize that the parity between what the accumulation is as you go through. That you always want to deal with the same kinds of things. Yep.
Do you set the accumulator to 0 on the lambda function, and then where you have accumulate plus current comma 0, you then put accumulator as a value there?
So,
Could you use the ACC in the beginning, set it to 0 for the default, and then after your comma, put ACC there?
nuh-uh. So ACC isn't available until you're inside this lambda function.
Okay, so it's not like a placeholder.
It's a placeholder. ACC is a placeholder for that function there. So this is the lambda. This is that initial value going through, right? So we're saying, hey, go through each of these. We're going to start off with an accumulated value of 0. So the first time through, ACC is 0. Current will be 1, right? And then we're going to return 0 plus 1. Yeah, it's
Sum is actually a function that creates new scope. And ACC and CUR are only available inside that scope.
Yep.
That's what I'm trying to get my head around. So it is a new scope.
Yeah, the comma that's after occur is actually distinguishing between the lambda function and the initial value, not occur.
Just an important note, if you don't see it with 0 in this case, then it's going to assume that the first value
Right.
in the array is actually your seed.
Correct. So you don't actually have to seed in the initial value. If you don't, it just works off the item 0 and item 1 off of, or index 0, index 1 in your array.
That only works with.
Gotta be careful.
Right.
Be careful though, yeah, because generally speaking, it's easier to understand when you get something. You can say, oh, what are we, what is the thing we're working through as we go with when you seed it. Also, if you try to do that with something that only has a length of, 0 or 1, you're gonna be in trouble. So what else can we do besides sum, right? Sum is kind of practical, and it seems like, you could probably write that in a lot of different ways. So how about this? We can take a shallow nested array, or an array of arrays, and we can use reduce to flatten it. So the result of that would be 1, 2, 3, 3, 2, 1, 5, 2, 1, all in an array, right? No more nesting. You can write a function that splits arrays. In this particular case, we're saying, hey, you passed in a chunk size, like 2. We're actually going to take that array, and we're going to reduce it to a new array of arrays. So it's just the opposite of flatten, right? We're going to split it.
Jared.
Yep. Who said that?
Me.
Oh, okay.
So the accumulator and the current, are those sort of always riding along with the reduce function?
Mm-hmm. You can, yeah, sometimes you'll like last, current, accumulative, current, LC, just depending on.
Are those keywords then?
No, they're just variable placeholders. You're just defining a function, and you can, a function that accepts parameters, you can name those 2 parameters whatever you want. Just in the function body, you got to make sure that you're consistent with the parameters coming in.
Okay. So here you have I all of a sudden. I'm not
Right.
seeing I anywhere else.
So
there it is. I see it. I divided by chunk size, right?
yeah. So map, filter, reduce, all these things, actually they all accept more than just the default arguments I've been giving you. I've just been showing you the bare minimum you need to pass in. There's more things you can do. So for instance, the third argument in reduce is the iteration number as you're going through. So first loop, I is 0, then 1, then 2, then 3, then 4. That way if you need to somehow use that index, and in this case, we want to add an array of arrays, and so we are creating index 0, index 1, index 2, each of those equal to whatever the chunk size is. I don't want to get too hung up on what this is doing. Just know that when you kind of have a good idea of how to use this, you can do a lot of really powerful things. It takes a little bit to kind of get your mind around if you're not familiar with the format. So we can compose functions, right? Here's an array that accepts n number of functions. It returns a function that, when called, will run whatever value you passed into that through each of those functions. Okay? This is using reduce right, which is just like reduce, except for it starting at 0 and 1, it goes from the end of the array to the beginning. So if we had just reduce here, this would actually be a pipe function, not compose. Essentially here is just an easy way to create compose. This accepts any length of arguments, each being a function, returns a new function. But now we can compose a bunch of functions together and pass that value through that.
So the ellipsis is a EC6.
ES6, yep. So that's called, rest and spread. That one's spread, rest. I don't know. Rest, that one's spread. Thanks. They're conceptually the same thing. This basically says, hey, you're going to give me a bunch of arguments. Just grab them up and put them in an array. That's all I'm doing. Saying, hey, they've passed in a whole bunch of functions as separate parameters, or arguments. I'm going to take that, and I'm just going to have an array of those arguments. That's all that's doing. So it gives me an array right at the very beginning. How about currying functions? Who knows what currying is? Same thing. I'm not going to get into how this is doing that, other than know I'm using reduce down here to basically say, hey, if you didn't give me enough arguments, return a new function. I'm reducing it to a new function where the previous arguments that came in are already applied. So curring, you can write curring with reduce. Same idea like he mentioned earlier about creating this waterfall. Here we have say we have an array of functions that when you execute are promise based, they give you a promise back, but you don't want to do them all at once for some reason. You want them to go one after another, after another, after another, after another. You want to wait till the previous one finishes before you begin the next one. This is that whole waterfall. Same thing. So we're basically saying, hey, turn this into this function that when called will execute any number of those things in order. Good? Kind of? So let's look at that, see if I'm lying. So here we're flattening, right? 1, 2, 3, 3, 2, 1, 5, 2, 1. We have this reduction. We're basically using concat. We know how concat works. We're using that to flatten it out. Here's split every. We're going to take this array and split it up to every 3. Right? Same thing. We get that over here. Here's a compose function. We're composing these two functions, something that squares it, or something that doubles it, something that squares it, right? Then we're going to double the square of 10. That gives us 200. And down here is curring, and us using them. And then the waterfall, I don't know if you saw that, kind of 1, 2, 3, right? So we basically just took these things and made them all go in sequence. This is new. It's kind of some of the other things aren't there to kind of like add confusion, just to show that there's a lot of power to be had there once you're familiar with kind of the different syntax. So, questions or comments about that? I got 5 minutes. Let's see. All right. Live coding, my favorite. This is what I put at the very end in case there's time. I hope I never have to do it. All right, so we have, this is common. We're consuming some API. The API gives us the shape back. The shape is an array of things that have a key value pair, right? And we want to actually take that, we want to make that into an object, so maybe we can have quick access to things, or a number of reasons why you'd want to do this. But we want to take an array of a key value pair to basically just this object with property names and values. And along the way, we want to get rid of some of these extra things that are meaningless to us, right? So if you think about what we have to do here, let's talk about what are the things, what are the verbs we'd have to use to do this?
We have to reduce that array of objects down to a single object.
So we have to reduce,
Filter out the garbage.
filter,
Map over the keys and pull out the values.
map. So I think let's give it a whirl. So we have the start shape. We want to turn it into that, right? So here's our start. First thing we want to do is what? What do you think? Matt? Filter? What do we want to filter? So key. Filter off the key. And what? So not. Try that. See if that gets. Oh. Thank you. So, okay, we've got rid of garbage, right? Yeah? None of the garbage keys are up here? Okay, now what? Reduce? Good. You want to try it? What would that reduction look like?
Reduce key value.
So what's the thing we're seeding at first? Let's start there. An object. Okay.
If we map before the reduction though, we would have a much cleaner reduction.
I agree, but well, I'm going with it.
Replace the current and output like the deconstruction.
Yeah,
key value.
deconstruction.
You want to deconstruct this?
Key of value.
Okay. So whenever you destructure this way, you have to, oh no, you don't. I was thinking, my bad, you're right. Okay,
Accumulation sets key equals. Return accumulation.
so we're gonna wrap these around. So we're gonna return a new object, right? Which is what?
Why would you
add it
return a new
into
object?
accumulative?
I would return accumulation after setting accumulation sub key to value.
Just making it a sub-function out of habit and best practice.
Is that gonna work? No, because there's something wrong. That one? That do it?
Depends on if order matters to you.
It's an object, so no. Objects don't, they provide no contract order whatsoever. That's what we wanted, right? I mean, that wasn't too painful.
How would you do it with map?
So map, I would probably map each one to an object, and then I would just combine them. So with map, it would look like, and this is probably, I mean, less stuff, so this works. So now we'll have an array of objects, right? Where? Oh, map. Thank you guys. So right, we'll have an array of objects. So if we would actually get rid of this here and run it. And then the reduce would just be kind of similar to the one before. Lies. Thank you. So.
Order matter on the.
Yeah, like it might change the display here, but I think you find different engines will handle it differently. Like, objects don't provide any guarantee. So. Questions, comments? Yep.
Can you remind us again what the dot is in ES6?
So that's object spread. And what it basically does is allow you to take an object and copy. It's a shallow copy. So this could be done with object assign, which is probably what it's doing under the hood anyway. But it's just taking an object and taking all the values in an object and doing a shallow copy to the new object. We're almost out of time, and I'm just gonna see. We are out of time. So another exercise, if you guys wanted to see. Same idea, there's the answer with the one there. Here's another one where maybe we wanted to append, like if we have, a bunch of different foods that we want to do that. You can find the answer to that is there. With reduce, very easy to kind of create a function that deeply flattens an array, okay? But all this is really to kind of set you up for the fun part that's coming up next time, or one time. Well, we'll kind of cover all these same things, and we'll start to compose these things together to build things. We're actually going to, use all these kind of lower level stuff, map, filter, reduce, all these things to construct bigger things using composition and kerning. We're going to programmatically create those filtering functions and things like that. Instead of just doing everything manually, you can start actually creating these functions. We can start negate things with true false filters. Just a lot more examples, but that's to be continued. That's next time. So good.